Hello everyone, very good day. Today we are going to look into the series of array problems, binary search. So binary search is an efficient searching algorithm. So if we have any sorted arrays, we can search the element lesser than order of n. In general, we have to linearly search the elements and find the respective element. So if we use binary search, it reduces into half. So we can achieve order of log n. So binary search has a conditions. So it will work on a sorted array, sorted arrays or list, duplicates. Even though it is sorted, suppose if we have a duplicates, like we have two twos or three twos, we'll be able to find the first occurrence of the two. And efficiency, so how much ever larger the data set is, it will compute and give you the target element in order of log n time complexity. Example, we have an array, sorted array, where we have 3, 5, 7, 8, 10, 12, 15. So we want to get 7. So 7 is an element where the index is 2. So the output is 2. So index 0 is 3, index 1 is 5, and index 2 is 7. And hence the output is 2. Moving on, we will move on to the implementation. So we will remove the space complexity and we will have this. So the time complexity is order of log n. I have created a class solution. I have created a binary search where it gets input of input array element and the target which we are going to search. For now, I am returning the index x minus 1, and I have a public static void main class where I have a array declared as a sorted array 2, 3, 5, 7, 9, 10, and I am printing the index as a result. So we will quickly run this program and check whether the template what we have created is right. Yes, element found at index is minus 1. It will always be minus 1 because we have returned minus 1. Now, we will move on to the implementation. So I am creating a variable left and initializing it as 0, and I am creating a variable right and initializing it as input array dot length. Now, what I am going to do is I will use a while loop, and then if left is lesser than or equal to right, now we will create a mid element, which is the middle one. We will start from the mid. So mid is left, and then I am going to do right. I'm also going to do right, and now we'll do it. If the target is equal to input array of mid, then it is plain and simple. So the middle element is the target we are looking for. Return mid. Mid is the index. Else, if target is lesser than input array of mid, then we will have to, what happens is if the target is lesser than mid, suppose we are searching, consider if we are searching 3 and if the mid is 7, so the target is lesser than 7. So hence the right should be mid minus 1. mid minus 1, else left is mid plus 1. Return so let it be return minus 1. So if this is a mid and if we are searching 3 and 3 is lesser than 7, hence we are making right as 5 and left as 2 and it goes on. So the mid is 3 and it will find the element 3. We will run and check whether our logic is correct. Yeah. So we are searching 7. So 7 is at 3. So 0, 2 is at index 0, 1 at index 1 we have 3, at index 2 we have 5, and in index 3 we have 7. So we will change the target and check. Suppose we'll check the edge case of last element 10. I'm running the current file. So we will see. Okay, we will check for 9 then. So we will go and check the logic here if we have done anything. Okay, we have found it. So it should be not right minus, it should be start plus, and we have, oh sorry, it is not start. We have to do like minus 1 and now we'll run. So the code is running. It says the index is out of bound. Yeah, so the index out of bound exception we got, so we have missed here. So it should be right minus left by 2 and left plus right minus left by 2, and we have missed the input array of length equal to 1. And now we can go ahead and search. Suppose we give 9, which is at 0, 1, 2, 3, 4th index. Now what we will do is we will check for 10, which we got an error before, and let's see. So it should be at the index 5 as usual, because 2 is at index 0, 3 is at index 1, 5 is at index 2, 7 is at index 3, 9 is at index 4, and 10 is at index 5. We will search for 2, and another edge case is at index 0. And yeah, so this is the logic for binary search and which runs in time complexity of order of log n. Thank you all for watching this video. We will continue the array series in the further videos for array related problems. Thank you once again for your time and patience. Have a very good day.